In today's video, we'll see how to use logarithmic differentiation. I'll start by explaining the procedure and defining the formula, after which we'll now see a solved example. That said, let's get into class. Welcome back. As a rule of thumb, we apply logarithmic differentiation when we have three functions. Now, take for example, let's take this for example. If I have y is equals to uv over w. Now, if I introduce ln to this, the ln of y obviously will be the same thing as the ln of u plus the ln of v minus the ln of w. This is just from basic logarithms. Now, we cannot differentiate this ln, but mind you that each of these, both my y, u, v, and w, they are all functions of x. We'll be saying that my 1 over y dy dx is the same thing as my 1 over u du dx plus my 1 over v dv dx minus my 1 over w dw dx. Now we're going to apply this. This is actually the basic principle behind logarithmic differentiation. And we're going to apply this in solving our problems. Now let's take an example. Our example wants us to solve for e raised to the power 4x over x raised to the power 3 cos 2x. If you look at this, you know that this is of the form of y is equals to u over v w. So that if I'm going to introduce logarithm here, it's going to become ln of y is equals to ln of u minus ln of v minus ln of w. Now, if I now want to differentiate this, it's going to become 1 over y. The differential of y with respect to x will be equals to 1 over u. The differential of u with respect to x minus 1 over v. The differential of v with respect to x minus 1 over w. The differential of w with respect to x. Now, let's pick each of them. Now, my u from what I have up here, u is the same thing as 4 e raised to the power 4x, sorry. So that the differential of u from function of a function, du dx, will be the same thing as 4e raised to the power 4x. Now, my v will be equals to x raised to the power 3, so that the differential of x raised to the power 3, that's the differential of v with respect to x, will be the same thing as 3x raised to the power 2. And my w will be the same thing as cos of 2x, which the differential of cos of 2x, that is the w dx, will be the same thing as 2 sine of 2x. Now, we'll place a link in the description for our lesson on differentiation using function of a function. That is actually a very big prerequisite to this lesson. Now, let's substitute in our formula. Now, I'll have my 1 over y dy dx will now be equals to 1 over u. U is e raised to the power 4x. That's 1 over e raised to the power 4x into du dx, that's 4e raised to the power 4x minus 1 over v. My v is x raised to the power 3. dv dx is the same thing as, that's 3x squared, 3x squared, and minus 1 over w. My w is 1, that's cos 2x, and my dw dx is 2 sine 2x. Now let's break it down further, so that 1 over y dy dx will now be the same thing as, here I have e raised to the power 4x over e raised to the power 4x. Both of them will give way, so I'll be left with 4. Here I have x raised to the power 2, I have x raised to the power 3. I'll be left with 1x here. That will be minus 3 over x. Then here I have sin 2x over cos 2x. This will be the same thing as minus 2 tan 2x. Minus 2 tan 2x. Now remember what I have here is 1 over y, and what I need here is dy dx. So that my dy dx will be the same thing as y into 4. I've only multiplied throughout by y minus 3 over x minus 2 times 2x. Now let's simplify that. Finally, my dy dx. Now in place of, okay, let me just write it out first. We say is equals to y into 4 minus 3 over x minus 2 times 2x. This times, not tan. Now, and we remember that our y is given as e raised to power 4x, not x, raised to power 4x over x raised to power 3 cos 2x. Now, so we can easily substitute for y in dy dx. So that finally my dy dx will be given as e raised to power 4x over x raised to power 3 cos 2x into 4 minus 3 over x minus 2 times 2x. Now with this, we've been able to arrive at our logarithmic differentiation of our y value. I hope you understand how to use logarithmic differentiation. We'll take further example in our next lesson. Thank you for staying with us, and see you in our next class.